Okay, so as promised, here is the first video, which is pages 1 through 3 in your Geometry Midterm Review Part 1 practice. I'm here with my colleague, Dr. Conklin, who teaches the other sections of geometry, and she's about to say hello.
Hello, everyone.
Yeah.
Glad to be here.
Okay, so let's look at number 1. The point 3, -2 is rotated 90 degrees about the origin and then dilated by a scale factor of 4. If you were to rotate 90, which is counterclockwise, if you did it with patty paper, or just rotating to the left one set of 90, you end up at the point 2, 3. If you then took the point 2, 3 and multiplied it by a scale factor of 4, you would then have 8, 12. Number 2. What is the image of point A, 5, 2, which I have marked right here, after a composition of transformations right here? Now remember, when the function notation is used, you always have to go in reverse order. So we're going to do this one first. Y equals x is this diagonal line that goes through the origin. You can put it on real graph paper and count diagonal boxes, or you just have to know that 5, 2 becomes 2, 5. So just swap the two coordinates when reflecting over y equals x. So after the first step, we're at 5, 2. Then we're going to take this one and rotate it 90 degrees. So that puts us at -5, 2. Before we move on to number 3, just remember, y equals x, diagonal line, but it looks backwards, y equals x, which is a reminder to you to reverse the coordinates, swap them. X for y, y for x, just take them and replace them with each other. Swap them. All right, number 3. Equation of a line that passes through both of these points. 3, -3, and -3, -3. If you're going to pass through both of those lines, you are a horizontal line that cuts through. I know it looks like the x-axis. It's horizontal, but it cuts through the y-axis at what number? -3. Okay, you've seen a lot of questions like this on warm-ups throughout the year. The equation of a line that goes through the point 4, 6 and has a slope of -3. So they give you an x, they give you a y, and they give you an m. So the equation of a line is y equals mx plus b, and you're looking for the new b. We're trying to solve for b here. So they gave us an x, they gave us a y, and they gave us an m. So now I have -6 equals -12 plus b. To solve for b, I'll add 12 to both sides, and I have b equals +6. The only choice that has a y-intercept of +6 is choice A. However, there's another way you could do this.
So another way you guys could do this is first, if we have a slope of -3, look down our row here, and does everyone see these are all -3? So that doesn't help us to eliminate anything. But what you could then do is if you go to your y equals button on your graphing calculator and you hit second table, the second graph, it will bring you to a table of points. But what you could do is take every one of these and plug it in to your y equals and see which one of these equations has the point 4, -6 in the table. And the only table that will have that is this A. So using your graphing calculator to check.
Awesome. Okay. Number 5. Same exact type of problem, right? So you can go to your graphing calculator and type each one of these in separately to y1. Hit second
graph. Yep.
Yeah.
Or it's the table function.
Yep. So we're going to think of it the same way as we thought the last problem, right? You can hit that on your calculator, look for the table, and you're going to look for the point 3, -1 somewhere on the list. And only one of those 4 choices will do that. Or you do it the other way, y equals mx plus b. They gave you an x, they gave you a y, they gave you an m. So -1 equals 6 plus b. Take away 6 from both sides, and you get -7. So it's the only one with a -7 for b. Okay. Number 6, which is the only transformation where the triangles will not be congruent? Popular question. A reflection, a translation, a dilation, or a rotation. Congruent means rigid, means angles and distance are preserved, which is the only one that angles and distance aren't preserved, obviously a dilation.
So we have a dilation here by a scale factor of 4. So anytime you don't have a picture, I would take a second to draw one. D, E, F. And then it's saying the image is being dilated by a scale factor of 4. So, I'm just going to do a little sketch here, a little bit bigger. D prime, E prime, F prime. So if you notice, our pre-image and image points are matching up. So one first important trick is anytime we're dilating a shape, the angles are going to stay the same. So all these angles should be congruent. But the sides are going to change. So this can be a little bit tricky, so we're going to highlight this to help us. So you can sort of get rid of C and D because those are talking about angles. If we look here at DE, here's DE, and here's D prime, E prime. Which one of these is bigger? Well, this one is way bigger. How many DEs fit in here? If I sort of went through, I could put 4 of these in here. So our answer would have to be 4 DEs. Choice B would tell us that 4 DEs fit into 1 D prime, E prime.
Okay, the ever-famous orientation question that seems to throw everybody for a loop. When we were just doing number 6, and we said dilation is the one that's different because dilations aren't congruent, you often feel like dilation's the oddball, the one that's always different, which is why number 8 is kind of tricky because with orientation, it is how you name the shape. So if I had, for example, ABC, and I reflected it, so I had A prime, B prime, C prime, if I was to check the orientation of A, B, C, it would be clockwise. But after any sort of reflection, if I go A prime, B prime, C prime, I'm now going counterclockwise. So that is a change in orientation, the way you name the points around in a circular fashion. So reflection is the only thing that changes, that has orientation changed.
Okay, so for number 9, I would actually tell you guys to look at the letters, not so much the pictures, because what we can do is if we look through, angle A is congruent to angle D. If you notice here, A and D are first. Ooh, so that's sort of promising. That might be an answer. If we go through and look at the other choices, A, B are the first 2 letters. D, F, not the first 2 letters, right? And then if we go through again and look at angle C and compare that with angle E, those are not in the right order. E's in the middle, C's at the end. And then last but not least, BC is here and DE is here. So again, those also aren't matching. So if we go through, there's only one that actually worked out to be true, and it was choice A.
Okay, number 10 asks you to take this line, 3x plus y equals 1, and dilate it by a scale factor of 5. The problem with this line is it's not in slope-intercept form. So we're going to solve it for y first by taking away 3x from both sides. Now it's in the right form that we can, it's a lot more workable. So now we take this equation, so you're not done yet. All you've done at this point is get it in the right form. Now you're going to dilate it. And remember that when you dilate a line, you only change the y-intercept. You never change the slope. It has to be parallel, so you keep the same slope, but multiply the 5 by the y-intercept of 1. So 5 times 1 is 5.
Okay, so for number 11, we have a block of wood, which is a rectangular prism. So this is a formula you guys learned a long time ago to find the volume, V equals length times width times height. So we're going to substitute in 5, 2, and 3. And when you multiply those out, you're going to get the volume is 30. And always make sure that your units are cubed because we're multiplying by 3 different terms. So number 12, we've done a lot of these in warm-ups this year. We have a volume formula, and this is our good old friend, the right cylinder, circular cylinder. So we're going to start by looking at our reference sheet, V equals pi r squared h, and the Regents loves to do this. Instead of putting the radius, they've put the diameter. So we're going to cut that in half and substitute in 4 for our radius, and our height is 10. When you multiply all that out, you should get an answer of D 502.65 inches cubed. Okay, so again, we're given a hint here. We're finding the volume for number 13, and we want to look at our formula sheet. 4/3 pi r cubed. Again, they give us a diameter, so we're going to cut that in half. V equals 4/3 pi, and instead of putting an r, we're going to put in 5. Now this says in terms of pi. So when you see the in terms of pi, it means it wants an exact answer, meaning we're going to multiply everything but this pi. So in your calculator, you want to put in 4/3 times 5 to the third. And when you multiply that out, you're going to get something a little bit funky. 498 over 3, and then you want to make sure to attach that pi there. Then it says for part B, find the volume to the nearest cubic inch. So I would punch that in your calculator, and when you do that, you're going to get 523.6, and this 6 is going to push it up, so your answer should be 524 inches cubed.
You're wondering, where did Mr. Fields go?
I was wondering that myself.
I was actually right here just double checking the answers with my TI-84 Plus graphing calculator. All right, so a right circular cone. Cones look like this. You're a better artist than me, probably. If the diameter is 6, remember the radius is 3. The height, it says, is 20. So if you go to that said formula sheet, which we'll also give you on the midterm, you'll have a copy of that. Volume of a cone is pi r squared. Now, I've taught it both ways. Divided by 3. I told my class if it's pointy, you divide by 3. Or the formula sheet itself says 1/3 pi r squared h. So either one's acceptable. We'll leave it like this for now. So if you type this into your calculator, 1/3 pi r squared h, you get 188.49, and it keeps going like this. Be careful. It says nearest cubic inch, 188 cubic inches. 15 is just like the one we just did, just an upside down cone. 1/3 pi r squared h, you're going to plug in the radius of 4, the height of 12, and it should come out 201. Number 16, we had a question like this Dr. Conklin did earlier, that you try to match things up. You don't even need the picture. So A, C are the first and third here. M, P are the first and third here. So look for the one down there that says AC is congruent to MP. And number 17, same type of question, except they also give you the picture. If you were to use patty paper, just visualize this. Where does Y go if I line it up? Angle B is on top of angle Y.
Okay, so this is telling us that M and N are cut by a transversal. So anytime we have a picture like this, I see a triangle right here. That's the first thing I want to sort of focus my eyes in on. And then I see 80 here. Always want to look for our friend, the vertical angles. These angles across, so this is also 80 degrees. And then 3 things. First, I would always look for vertical angles. I'd look for triangles because they add up to 180. And then the last thing we want to look for is supplementary angles. So if we look here, we have 3 angles that add up to 180. So I'm going to take the 30 and 80, and that gives me 110. These 2 angles are 110, and then when I do 180 minus that 110, that gives me 70. So if I know this angle up here is 70 degrees, and I want these 2 lines to be parallel, then I want to look for what kind of special angles. This 70 has to be the same as this X because they're alternate interior angles.
So the next section, which I think is going to be pages 4 through 7, will be posted by Monday night, and then every night after that we'll go work our way through the packet. Good luck.
Bye.